Assalamu alaikum. Hello everyone. This is lecture 1 of software requirement engineering. My name is Muhammad Reis and I will be teaching you about this course in the summer 2020. This course will cover fundamental, theoretical and practical aspects of collecting requirements from the user to develop a particular software system. So let's start formally by looking at the contents of lecture number 1. So in this lecture we are going to start our discussion with the discussion of engineering and software engineering. We will focus on the role of software requirement engineering in the software development lifecycle processes. Then I will discuss about different types of engineering projects and how requirements are connected or dependent on particular users and interactive systems. And then we will overview a requirement engineering life cycle and the role of requirement engineering in particular software development life cycle. Then we will focus on two types of requirements, namely as functional requirements and non-functional requirements. So as you are studying the course of an engineering domain, you should first understand what is an engineering degree or an engineering program. So engineering by definition is the development of cost-effective solutions to practical problems through the applications of scientific knowledge. So here we can identify few critical pivot points or keywords for the definition of engineering. So first of all, we had a word cost effectiveness. So engineering is a systematic plan that ensures that each and every solution is cost effective and it meets the needs of the problem or it addresses a particularly new problem. So how it is achieved? It is achieved through the application of scientific knowledge. So main thing was cost effective, that your processes and design should be cost effective and there should be minimum resource usage. And you should also minimize the negative impacts of your solution on the environment and social networks. Secondly, it should provide a solution, and the emphasis of engineering is to provide novel solutions or to find out the solutions for existing problems or to discover the new solutions for existing problems which have already been found a solution. So emphasis on in software engineering will be on building new devices or software products. Then the problem should be practical. You should solve problems that matter to people, and you should improve the human life in general through the technological advances. And it is the application of scientific knowledge as well. And most importantly, it is the systematic application. That means you have to first identify the problems, identify the possible solutions, and then apply those possible solutions in a systematic manner to achieve the desired results. So software engineering is a discipline for systematic production and maintenance of software developed by a team. So there are particular characteristics which we have discussed in the previous slides. The first one is the development of solution, and your solution should be fault free, that it should provide benefit to the consumers or general people without any failures. And secondly, it should be cost effective, and cost can be measured in two parameters such as time and money or budget. So your product, if managed through an engineering process, should be delivered on time, and it should be constrained with the required budget. And finally, it should satisfy the stakeholders' needs. And the goal of the software engineering is to uh, develop quality software on time, on budget, and that meets the customer's real needs. So it is another way of saying the same thing as described in the previous slide. So a software is good only if it meets stakeholders' expectations. So if your client or any party or stakeholder that is interested to build your system, if that party or a client is satisfied with your system, your software is bound to have a good quality. So it is at least correct, reliable, maintainable, and user friendly along with many other requirements. And the total cost it incurs over all phases of its life cycle is minimal and within the budget. So resource constraint is provided along with some quality attributes which will be discussed in upcoming slides. However, stakeholders are varied. It depends upon the different stakeholders that what a particular requirement they are looking for. For example, some stakeholders are more concerned with the non-functional requirements such as reliability, maintainability, or user friendability, and some stakeholders may be more concerned about the time and the budget constraints of your software product. So to develop any solution, requirement engineering plays a crucial step to identify and elicit the needs of particular stakeholders or users of your system. So requirement engineering covers all the activities involved in discovering, documenting, and maintaining a set of requirements for a computer-based system. So it manages all three aspects. For example, first of all, your requirement engineering process should be able to discover requirements from the users and from other stakeholders such as an existing system or by a comparative studies from the industry. And after the elicitation of the requirements, your requirement engineering process should have a component that documents those requirements. Because if you do not document any of the requirements between yourself and the users, then you will not be able to build a particular kind of product which will meet these requirements. And third of all, you have to maintain those set of requirements for a computer based system. That means you have to manage the changes or modifications provided by the user or changes occurred due to some implications from a regulatory body to implement in software uh, based systems. So the requirement engineering is the process of establishing the software services that the customer requires for a system and the constraints under which it is operated and developed. So requirement engineering is a process that covers the broader aspects of your systems, and it requires to establish the services that the consumer needs from your system and also the constraints under which it operates. For example, if you take the current banning of different applications in Pakistan, the sure requirement engineering process should be able to manage these constraints and under which of these constraints your application is operated, and in the same way it should be developed. So the why term engineering is used here. Again, it is a systematic process that it is not like you pick up a process by default and you start implementing uh, your requirements into the code. You have to find out a systematic procedure that would elicit all the requirements that are functional, non-functional, or any specific constraints that are put by a regulatory body, a government, or any social systems on your system. So you have to ensure that requirements are complete, consistent, and relevant. So at the start of any new project, the requirements are depicted in an abstract manner, that there are no specific requirements uh, except for a desired outcome, that what should your system provide to users. So here is a typical example that how a company can use a particular requirement abstraction technique to find out about a further requirement refinements. So you can go through this description here. So let's start with the definition of requirement. What a requirement actually is. So as an IEEE standard glossary of software engineering terminology 1990, a requirement is a condition or capability that is needed by any user to solve a problem or to achieve an objective. Similarly, a requirement is also defined as a condition or a capability that must be met or possessed by your developing system or the component of your system to satisfy a contract, which is usually between two parties. One is developing the application and the other is using or the consumer of the application. It must satisfy a contract or a standard specified by a third party or a regulatory body, specification, or other formally imposed document. And the requirement must be documented, and a documented representation of a condition or capability as described in point 1 or 2. Similarly, there are further definitions by different authors. For example, if you refer to the Somerville book from the 1997, requirements are again a specification of what should be implemented in your system. They are description of how your system should behave, or system property, or an attribute. They may be a constraint on the development process of the system. Similarly, there is another definition from another book which states that the requirement engineering is the branch of software engineering concerned with the real goals or functions of and constraints on software systems. It is also concerned with the relationship of these factors to precise specification of software behavior and their evolution over the time and across software families. So in general terms, a requirement or software requirement is the ability of your system to perform a specific actions that is desired or specified by its users. So by proper the requirement engineering, we can define that we should know what the system is supposed to do, and we should keep track of the current status of the requirements, and we should be able to determine the impact of the requirements change. So you have to manage all these three to maintain a systematic requirement engineering process that will lead to good product quality eventually. So generally there are multiple ways to identify the requirements. So at the initial step, the requirements are gathered from the stakeholders. So you can identify the needs and the wants of the stakeholders, and you can put these needs in a requirement gathering process or document. Then you can look for intended operating environment, that in what circumstances your system will work, and you can We use these requirements and requirements gathered from the stakeholders to model a system, and which will eventually lead to a software specification document. Then, after the system modeling and specification, you convert these requirements to form a product design. So when the design is formed, you can ask the users to give feedback on the design to further improve your requirement gathering process. So if the improvement is positive or if the improvement requires changes, you can go through this loop and you can further improve the design specification to construct your product. And again, you ask for the feedback to further improve the requirement engineering process. And thus product is delivered to the user, and again product feedback is gathered to further improve the requirements that will be implemented in the next version of the product. So requirement engineering is a very essential process in the software development life cycle, and it is referred as the hardest single part of building a software system is deciding what to build. So it is very important to know that what you are going to build. Unless you know the information about the actual outcome of your system, you will be going aimlessly in no direction. So no other part of the conceptual work is so difficult as establishing the detailed technical requirements. So it also includes the interfaces to the people, interfaces to the other machines, and to other software systems. So though no other part of the work so cripples the resulting systems if done wrong. No other part is more difficult to rectify later. So as we will see in the upcoming slides, that faults caught at the requirement engineering process are easy to manage and handle. And if you catch a fault in the requirements at the later stage of the software development life cycle, it will be very difficult to accommodate the changes and to cater the needs of budget and time. So the requirement engineering is an important process of your software development life cycle. So it is also embedded with some definitions from uh, famous author Urban Wisdom and Software Engineering Institute. So delivery is not necessarily the best time to discover the user requirement. It is stated that the user requirement should be elicited at the start of at the start of your software development life cycle. And Software Engineering Institute SEI also says that if the requirement engineering are done well, the it it presents an opportunity to reduce the cost and increase the quality of your systems. And if the requirement engineering process is done poorly, it could lead to software project failures. So by the time you reach at this slide, you should be well aware that the requirement engineering process is very essential for developing quality products. Why it is the most important process or part of your software development life cycle process? Because if you do not have the clear view of the requirements, you will be wasting your resources such as human power, time, and money into the wrong directions. So if you do not have the right requirements, you will be going in a different direction, and it will be very difficult to recover from that position to actually build the software that is needed by the user. So this diagram clearly depicts that if users and the developers of the systems are not on the same page, different products will be the result of your software development lifecycle, which may not be very useful for the users. So requirements also serve the role of a contract, which is an integral part of dealing with two or more parties. So set of requirements constitute a contract between client and the software developer, and it is an essential document to have before starting the development of any software product. So if you do not have the contract, you will not be able to measure the outcome or the quality of your product. And software requirement documents are medium used to communicate requirements to technical people such as developers responsible for developing the software. Requirement documents should emphasize user behaviors and activities. It also serves a basic project planning such as to schedule and to form budgets. Requirement documents is also used both to drive the design stage and the basis for test planning, because you are planning to test your product against some predefined requirements that whether or not your product meets the specified requirements. So here is a survey from a Standish group report, and in reality, it states that about one third of computer software projects get cancelled before they are completed due to wrong estimation of the requirement, and 50% of those will overrun their initial cost estimated by as much as 189%. And it also states that 95% or 94% of project startups are restarts of previously failed projects. So requirement engineering as a, a peremptory step, and it must be done with the clear uh, goals. So as I described earlier, the cost of correction is very high if you recover a fault in your requirement or discrepancy from your requirement document and the needs of the user. So if a unit cost of 1 is assigned to the effort required to detect and repair the error during the coding is referred as 1. For example, if you are investing 1 million rupees on your product, and if you say that recovering one requirement at the coding costs you about 1000 rupees. Of course, if you recover the error before the coding, it will cost you less, because the least amount of time you have spent developing the product, the least amount you have spent uh, on the resources and uh, time of developers. And if you catch the fault later in the process, such as at the unit testing, accepted testing, the cost is usually multiplied by 2 to 5 times. And if the fault is made at the maintenance steps, such as after the deployment of your application, your cost can reach up to 20%, 20 times of your initial cost. So the requirement engineering process is also referred as the the most probable root cause of project failures or success rate by the same Standish report. And the three largest problems in the software industries are lack of user input, incomplete requirements and specification, which is again refers to the user input, and changing requirement, which is again related to the users and the stakeholders of the system. And collectively, about 37% of the projects were failed or related to the requirement uh, gathering failure process. And the success factors are also identified by the same report, and it supports that about 16% of all successful projects incorporate the user involvement and executive management support along with clear statements of the requirements. So as uh, described earlier, that the major problem should be addressed at the start of your software development life cycle, and minor problems should be addressed later in the um, SDLC processes. So if you have a major problem, you should be trying to recover it in the requirement specification, management, and documentation, or later up to the software development and testing phase. And if there are minor problems, you should cater in the middle phases, and if the problems with the lower risk can be managed at the later part of your SDLC. This is a very aesthetic way to represent the user satisfaction and quality requirements. So two parameters are measured positive. One is the satisfaction of the user, and second is the requirements being met. So as you meet the requirements, most often you are moving towards the better quality of your product. And similarly, if user is satisfied with your product is bound to have more quality. So as you can see, if you have high satisfaction rate and if you meet all of the or most of the requirements, you will have the exciting quality of your product. And if you do not meet the requirements, and if you have dissatisfaction of the user, you will be most probably here. So requirement engineering process is applied to all engineering domains, but it is a little bit different in the software domain, because software is different from other engineering products, because software cannot be seen, it cannot be touched, and it is an abstract product. Software alone is useless. Its purpose is to configure some hardware to do something, and there is no physical laws underlying the software behavior. There is only computational laws which applies to the computational powers of your system. And there are no physical constraints on the software complexity. It can be as complex as the uh, human mind. Software can never wear out, and traditional reliability measures do not apply to the wear out of the software. Software can be replicated perfectly, and there is no manufacturing variability. You can produce multiple copies of same software without any error. And there are some myths about the software which can put some implications on software requirement process. The first myth is the cost of the software is lower than the cost of the physical devices, and it is not very much accurate in practical terms. Software cost in these days is much higher than the hardware cost. Secondly, it is a myth that software is easy to change. If you have developed a software which provides maintainability, then it is easy to change. However, it is very difficult overall to change the functionality of any software. Similarly, computers are more reliable than physical devices. So it is also a myth, because computers also fail and run into many problems in which physical devices do not. software can be formally proved to be correct, and software reuse increases the safety and the reliability, and computers reduce the risk of mechanical systems. So these are some myths which are not correct in every case. So every engineering product will be accompanied by the needs of the stakeholders. So your requirement document should cater the needs of the stakeholders. And the first step you can do is to contextualize the stakeholders' requirements. And these are usually the first uh, stakeholders in your SDLC can be the sponsors or the initiative owners, which can be clients or the users of your system. And these provide some input to form the requirement documents. And you also have to contextualize the other stakeholders that provide constraints on your system. It can be an industry regulator such as quality standard or regulators such as the PTA in Pakistan. And there are certain risk factors that must also be constrained, such as time and the implications of software in any society. The outputs of your projects are directly linked with the customers and customer service operators and to salespeople. You have to also analyze the uh, outputs, output stakeholders as well. And there will be some additional stakeholders which will be managing the requirements. These will be project managers, product managers, and customer service managers. So who are the stakeholders? Stakeholders can be customers who fund a project. Stakeholders can be users who interact with your system. Stakeholders can be requirement analysts who write your requirement. Stakeholders can be developers. Stakeholders can be testers. They can be documentation writers. They can be product managers. They can be project managers. They can be a legal staff, they can be a manufacturing staff, and they can be sales or marketing people. So anyone linked to your system in one way or another is the stakeholder of your system, and your requirement engineering process should cater the needs of all the stakeholders. These stakeholders interact with your system in various ways, and projects are initiated through a wide range of possibilities. For example, one way a project can be initiated is the problem-driven approach. For example, you are working in any organization or a sector, and a new problem has arisen, and that demands a new response. Therefore, you have to develop a new project. For example, it may be a case due to an existing system is broken or there is no functionality in the existing system. Similarly, you want to change some functionality in the existing system project. A new project can arise from such circumstances, and in the same way, the existing system may become less useful and you require a new system. Similarly, it can be due to an opportunity driven, a new technology opens up new possibilities, or there is a new trend in the environment or society, such as changing environment or new policies implemented by the governments or the regulatory bodies, which create new opportunities to start a new project. And the final way to start a new project, it can be legacy driven. That means some earlier project was unfulfilled, therefore you will start a project to fulfill the requirements of the previous project. And there can be more than one source of requirements, and the first and the foremost is the customer. So customers with the specific problems are main source of your requirement gathering process. You can also do a market survey which will help you to identify that how systems should be designed to be sold widely. Similarly, you can also look at the alternatives that how your system can be socially useful. In this case, you will usually have no paying customers, and your software should be some open source or free software created in the scientific research. And you can also use a hybrid approach which can use any or all of the desired forms. So software can also have various forms and shapes, and one of the most used form of the software is the information system. These systems support organizational work such as your CMS or any system used in the offices or other institutes. It includes files, databases, as well as applications, and more than 70% of all softwares fall in this category, and these are written in languages such as C, Java, C++, C Sharp, Python, and PHP. So the examples include payroll and personnel systems to manage the employees, financial transactions which are used in banking systems, customer relations, and databases, etc. Software can also be used to control systems, and it derives some sort of hardware processes. For example, software used in flight controls, industrial plants, or elevator systems are some examples of control systems. There can be some generic services systems that provide some services for other systems. Examples of such systems are internet applications such as search engines, stock code services, credit card processing, etc. These systems are also developed using variety of languages and middlewares including Java, C++, HTML, CSS, etc. So project can also have different context. For example, you will be developing a system with an existing system, and it may just be a set of an ad hoc workarounds for the problems. And if you want to avoid the weaknesses of the old system, you have to study it before developing the new systems on the existing system. Similarly, you can also use some pre-existing components, and it will dramatically reduce the development cost, and it will be easier to decompose your problem if some sub-problems are already solved in another system. Similarly, you can have multiple families of your products. For example, you can have the basic version, or you can include an advanced version or the pro version of your software system. Similarly, you can have horizontal families with similar systems used in the related domains. So this means you have the different versions of your systems in different environments or in different countries. So I will reiterate here that the requirement engineering is a broad spectrum process which can have further systematic processes to achieve the best quality product. And usually requirement engineering practices are observed in most of the organizations, and the project vision and scope of your projects are clear definitions of your software requirement specification document, which will provide a comprehensive and yet a very concise view that is the scope or vision of your document. That means how your system will be operated and what is the benefit from your systems and what are the constraints on your system. So users surrogates such as product managers, development managers, user managers, marketers claim to speak for the users, but they do not actually represent the user needs. So whenever developing a system, you have to reach to the end users and observe their steps, that how they interact with the work, so you can use that knowledge to incorporate into your system that will best facilitate the users. So we will learn about the practices to gain the requirements from the users. So requirements exist in the heads of the experts in your organization and are never written down. So it is a very problematic process in some organizations, that some people say that they know the requirement and what they want to build, but they cannot explicitly state their requirements in a document form, so that other people cannot uh, learn or understand what is the actual outcome desired by the experts. Therefore, it will create a gap and ambiguity between the team, that what is our goal. Another practice is that customers claim that all requirements are critical. And it is also one of the major problem, that every customer says that every requirement they are saying is the top most important and it has the top priority. So they do not prioritize themselves. So they place every requirement at the top. Additionally, developers encounter ambiguities and missing information when they start to code, so they have to guess. So sometimes they guess right that what is actual expectation of users, and sometimes they get it wrong. And most importantly, communication is required between the developers and customers to focus on the user interfaces, displays, and not on what the user need to with the software. And your customer sign off the requirement and then change them continuously. So this is also one of the problems, that your customers give you a document and then they say they need another product or change in that product. The project scopes increases when you accept the requirement changes, but the schedule slips because no additional resources are provided and no functionality is removed. Requested requirement changes get lost and you and your customers do not know the status of the change request. Again, customers request certain functionality and developers build it, but no one ever uses it. So this is also one of the requirement engineering practices. And finally, the specification is satisfied, but the customer is never satisfied, because the ambiguity in their mind and in their explicit document specifications. Requirements also have different types, and the fundamental types of the requirements are the business requirements, and these represent high-level objectives, that what business you want to achieve from the software product. These specify the goals of the stakeholders for the product, and it also specifies that why and what the system will be, what goals they are trying to achieve, and usually it is covered in the vision and scope of your requirement specification. So as I said earlier, vision should include what is the objective or goals, that what you want to achieve from your product, and what is the constraint that is put on what environment your system will work in. So when you are done with the business requirements, you have to deal with the user requirements, that are statements in the natural language plus diagrams of the services the system provides and its operational constraints. These are written for customers. And additionally, there are system requirements, which specify a structured document setting out detailed descriptions of your system's functions, services, and operational constraints. So it defines what should be implemented. So maybe part of the contract between a client and a contractor. The term system requirement describes the top level requirement for a product that contains multiple subsystems, that is a system. System can be of all software or it can include both software and hardware subsystems. People are part of system too, so certain system functions might be allocated to human beings. And there are two types of the system requirements known as functional requirements and non-functional requirements. Statements of the services system should provide how system should react to a particular input and how system should behave in a particular situation. And it may state that what system should not do. Similarly, non-functional requirements are the constraints on the services or functions offered by the system, such as timing constraint, constraints on the development process, standards, etc. It often applies to the system as a whole rather than individual features. So function requirements refer to the features or the functions, and non-function requirements refer to the quality of your product and features on the whole. And there are some domain requirements which constraints on the system from domain of operation and in which domain your system is going to be used. So here is an example for an MHS hospital management system for a patient management system for mental health care. So I would like to read this statement and identify the functions of the systems and identify non-functional requirements which put constraints on your system and identify any further requirements that can be a type of domain requirement or any business objective. So if you have read the requirements and you can specify the requirements in user requirement definition and system requirement definition as described here. So as described earlier, there can be several levels of requirements and the initials are business requirements, that what business you want to achieve from your product. So these are usually referred in vision and scope documents of your product. So when you are done with the business requirement, you will move to the requirements desired by the user and you will make a use case document. We will learn about making use case documents in next few lectures. And then you have to identify the system requirements to put on functional requirements with the combination of use cases and system requirements. And there are some specific business rules which can be applied to the use case documents, functional requirements, and quality attributes. Quality attributes can also be applied to functional requirements and a software requirement specification. Your software requirement specification is the final document that can be produced after the software requirement engineering process. So it includes all the desired uh, parts of your requirements. So it will include the business requirement in the form of vision and scope document. It will include user and system requirement in the form of functional requirement represented in the definitions of use cases. It will provide the limitations, constraints of the business rules quality attributes. It will also provide interactions of the system with the internal and external interfaces and constraints put on by the domain, the legal system, or any other standard imposed by the third party uh, organizations. So let's look at each type briefly, and the first type referred here is the business requirement. Again, business requirement represent high level objectives of the organization or the customer who requests the system. Typically, it comes from the funding sponsor for the project or an customer you want to uh, wanting to buy from you or the manager of the actual users. So these are recorded again in the vision and scope documents, sometimes called a project charter or document, market requirement document. So defining the project scope is the first step in the controlling the common problem of scope creep. So here are some examples of business requirement. So consider a word processing program. So a business requirement might be like this. The product will allow users to correct spelling errors in a document efficiently. So as you can say, it is a broader scope which tells what the actual outcome of your system and what are the constraints. So here the actual outcome is the correction of spelling errors and the constraint is the efficiency. So again, corresponding user requirements might include tasks such as use cases, such as to find spelling errors, which is a functionality, or to add word to vocabulary, which are the lower form of the business requirements. The product post covers announces that a spell checker is included as a feature that satisfies the business requirement. So it can be an individual function requirement which deal with the operations such as finding, highlighting, misspelled word, etc. If we move lower um, towards the user requirements, the user requirement document describes user goals, that what the user want to achieve from the system and how it will achieve from the system, and the task that user must be able to perform with the product. These are valuable ways to represent user requirement, and it must include use cases, scenarios, descriptions, etc. So an example of the user requirement can be make a reservation. So now you can differentiate between the user requirement and the business requirement. The business requirement was the actual goal of your system or the actual outcome with the constraints. However, the user requirement is very specific, that what your user will do with the system, such as making a reservation using an airline or rental car or a hotel website. An example scenario can be get a cash from the ATM, and it can include entering the PIN and cash provision use cases. Then, as we described earlier in the slide of the uh, levels of the requirements, we discussed some business rules are also part of your software requirement specifications. Business rules include corporate policies, government regulations, industry standards, or accounting practices and computational algorithms. Business rules are actually the working of your businesses in real industry. So certain corporate policies may apply to any certain organizations. Government regulations might also be applicable to some applications, such as which interact with the government industries, banking systems, or social systems. There can be some industry standards such as ISO, International Standardization Organization, or capability maturity model (CMMI), which put certain standards to be to the product to have a certain amount of certain level of quality. And there can be some accounting practices and computational algorithms which must be incorporated in the product or also part of your requirement document in the form of business rules. However, business rules are not the software requirement because they exist outside the boundary of any specific software system. However, they often restrict who can perform certain use cases, or they dictate the user that the user must contain functionality to comply with the pertinent rules. Sometimes business rules are the origin of specific quality attributes that are implemented in the functionality. The most important part is the functional requirement, which specifies the software functionality that the developers must build. Now the focus has changed to the developers, that what should they build to in order for the product to meet the requirements specified by the user, or to enable users to accomplish their task, thereby satisfying the business requirement. Function requirements describe what a developer needs to implement. Almost any action, calculate, inspect, publish, or most active verbs can be a functional requirement. So examples include the system shall email a reservation confirmation to the user. So it is a very well defined function requirement that at any step your system should email a reservation confirmation to the user. Another example states that the product shall predict which road sections will freeze within the selected time parameters. So functional requirements vary with respect to the type of the software, expected users, and the type of the system where software is used. Functional user requirements may be high-level statements of what the system should do. Function system requirements should describe the system services in detail. So here are some examples of the function requirement. For example, in the first requirement, it states that system shall solve a quadratic equation using the given formula. Another requirement states that the user shall be able to search either in the entire database of the patients or select a subset from the databases. System shall provide appropriate viewers for the users to read the documents in the document store. And there are some other requirements. So here you can notice that the level of detail is different requirement in different requirement is described above. Some are very detailed as compared to the other. Notice the ambiguity in the requirement which uses the term appropriate viewers. The requirement does not mention the formats of documents and types of the viewers which can be used. So you can also notice the ambiguity in the requirement for solving the quadratic equation. The requirement does not speak about the possibility of value a is 0. So incomplete and ambiguous requirements are open to multiple interpretations, and developer can make assumptions which will lead to deployment of poor quality, faulty software products. So here is again examples of function requirements gathered from the previous case study referred as mental hospital system. So I will leave it to yourselves to find out the function requirement from that case study. And another form of requirement is the domain requirement, in which the system's operational domain imposes requirements on the system. For example, a train control system has to take into account the braking characteristics in a different weather conditions. Similarly, domain requirements, the new function requirements or constraints on the existing requirements, or it can define specific computations. So if domain requirements are not satisfied, the system may be unworkable. For example, a domain requirement may specify that your system should be able to work on multiple operating systems. So if it is not able to work in multiple operating systems, your system will be unworkable. So you have two domain requirement problems. The first one is understandability and the second one is implicitness. Requirements are expressed in the language of the application domain. That means you have to learn the domain of the application to understand the domain requirements. This is often not understood by software engineer developing team, and you need an expert from the industry of the same field in which you are going to develop the product to comprehend the requirements. For example, if you are developing a system such as described in the previous slide about the mental health cases, and there will be some psychological terms which you will not be able to understand on your own, and you have to consult industry or domain specific people. Similarly, domain specialists understand the area so well that they do not think of making the domain requirements explicit. So it can be a problem that if you talk to a specialist psychiatrist, they will feel that the terms they are using are easy to understand for a software engineer, but it is in most cases it may be implied that these are difficult to understand. So there can be some chances of implicitness. So here is an appropriate example of domain requirements for train protection system. The requirement states that the deceleration of the train shall be computed as the train, the control plus the gradient. So where d gradient is 9.81 meter square multiplied by compensated gradient slash alpha, and where the values of 9.81 multi meters per second square slash alpha are known for different types of trains. So it is difficult for a non-specialist such as software engineer to understand the implication of this and how it will interact with the other requirements. So there can be some opposite requirements or inverse requirements. For example, the system shall not use a red color in the user interfaces whenever it is asking for the input from the end user. So here are some examples of the requirements. For example, the first requirement states that the system shall maintain record of all payments made to employees on account of salaries, bonuses, travel, daily allowances, medical allowances. So as you can see, it is the broader term and it can be referred as the requirement for business cases. The system shall interface with the central computer to send daily sales and inventory data to every retail store is another example. And the third example states that the system shall maintain a record of all library materials including books, serials, newspaper, magazines, videos, audios, tapes, reports, collections, and transparencies, etc. So you can go through the next few requirements on your own. So if we move further to the requirement specification documents, and one of the uh, important contender is the quality attributes or non-functional requirements. So users naturally focus on specifying the functional requirements. They do not provide the non-functional requirements by default. These functional requirements are the behaviors of your system, that how your system should operate. But there is more to the software success than delivering the right functionality, and these are the quality attributes or non-functional requirements. So users also have expectations about how well your product will work. It is not about doing the task, it is about doing the task efficiently. So characteristics that fall into this category include the, for example, it can include how easy it is to use your system, or how efficient it is, or how often it fails, or how it handles the unexpected conditions. So, along with this and many others, such characteristics are known as software quality attributes or quality factors that are part of the system's non-functional requirements, also called non-behavior requirements. So non-functional requirements, abbreviated as NFR, also defines the system properties and constraints such as reliability, response time, storage requirements, constraints on input-output devices capability, and system representations. Customers generally don't present the quality expectations explicitly, and they consider that these requirements will be catered in implicitly by the uh, developers. So most users won't know how to answer questions such as what are your interoperability requirements, or what your application should interact with, and how reliable does your system have to be. So they do not have the accurate answer. They want their system to be highly reliable. However, highly is not a measurable term, and they want their system to interact with other systems, but they do not know what are the other systems. So the analyst has to develop several prompting questions based on each attribute that might be significant. For example, to explore the integrity of chemical tracking system, ask how important it is to prevent a user from viewing the orders they did not place, or should everyone be able to search the stockroom inventory? Now everyone is placed as quantitative measure, and how important can be scaled from 1 to 5, that how important you want it to prevent users from viewing orders they did not place, from 1 being very important and 5 being very less important. So from technical perspective, quality attributes drive significant architectural and design decisions, such as partitioning system functions onto various computers to achieve several performance objectives. Non-functional requirements may affect the overall architecture of the system rather than the individual components. For example, to ensure the performance requirements are met, you have to organize the system to minimize communication between components. So in real systems, the software non-functional requirements are collective sum or sub-part of your functional requirements. Meeting the non-functional requirement is often more important than meeting functional requirements in determination of systems' perceived success or failure. Here are two uh, definitions or requirement specifications for non-functional or quality attributes which can be measured. So for example, if you look at the first example, it states that the system shall provide access to legacy course catalog database with no more than 10-second latency. That means it is a measurable non-functional requirement that whenever you query your database system, it should provide you response within 10 seconds. And if every time it provides you a response within 10 seconds, you can assume that your system provides this attribute or non-functional requirement. So it is referred as accessibility of your system. The second example states that your system shall support up to 2000 simultaneous users against central database at any given time. So again, it is the requirements of support of users or availability to 2000 simultaneous users. So you can conduct a test by employing 2000 users, and if your system supports the working of 2000 users at the same time, you can see that these requirements have been achieved. And again, there is another requirement linked with this which says that up to 500 users against the local servers at any time. So this concludes today's lecture, and if you want to read more about the topic, you can look into this recommended book. Thank you very much. If you have any questions, you can ask me through any of the designated mediums such as CMS, YouTube channel, or WhatsApp group. Thank you very much.